In this video, we're going to look at the measures of the center of data. We're going to determine the most appropriate measure of center, measure of variation, and measure of position. We're going to interpret the meaning of center of measure, measure of variation, and measure of position. And then we're going to recognize the basic distribution shapes of uniform, symmetric, skewed, and bimodal. So when we talk about the skewedness of a histogram or the graph of the data, we want to talk about what we see. Now, this first example here, we can see it looks pretty uniform all the way across. So we would say that this is uniform distributed data. The box plot that would represent a uniform, not necessarily this one, but a box plot that would represent a uniform distribution, would have this whisker length will equal this whisker length will also equal the length between quartile 1 and the median and quartile 2 or quartile 3. So that's how you know that with a box plot you have a uniform distribution. Now, when you have a uniform distribution, whether it's a histogram or whatever, you're going to have, and what I mean whatever is the box plot, so a histogram of a box plot, the mean, when we have uniform, the mean and the median are about the same. They're not necessarily have to be the same, but they're pretty close to being the same. And that reflects that whole nature of being distributed evenly or uniformly. The data set itself could be unimodal, which means it only has one mode, or it could be bimodal, depends on how the distribution is. So if we look at this example here, it is clear that number 7, based on the graph, has the highest frequency. Now, with that said, if number 3 also from 2 to 3, so let me come up here, between 2 to 3 also went up that same distance as from 6 to 7 did, then we would say it's a bimodal, that this interval and this interval happened the same amount of time, so we would say that it has 2 modes, or it is bimodal. That's what it means to be bimodal. On the other hand, bimodal refers to a distribution or histogram that has 2 distinct peaks or modes, which we just talked about, indicating that there are 2 separate values or ranges that have the same high frequency. In a bimodal distribution, there are usually 2 distinct central tendencies. The next one we're going to look at is symmetrical, or sometimes called bell-shaped distribution. It has whatever you see on one side of the mean, median, mode is the same on the other side of the mean, median, and mode. Now, if we are perfectly symmetrical, the mean, the median, and the mode should all be the same, and it should be right here in the center. So this is an example of a bell-shaped or symmetrical histogram. Now, this, you can see, has the whisker on this side from the minimum to the first quartile is approximately equal to the whisker from quartile 3 to the maximum. And these distances between quartile 1, the median, and quartile 3 are much shorter than the whiskers, and the distance approximately from the quartile 1 to the median and the median to quartile 3 are all approximately the same. In this example, it is unimodal, and it has the same mean and median for this example. This doesn't necessarily, of course, these are not necessarily the same thing, and you clearly see these are not, because I would expect my mean to be right here at 7, and this one is at 3. So these are just 2 different examples with a histogram and a box plot. This box plot does not represent this histogram. In a symmetrical distribution that has 2 or bimodal, the 2 modes would be different from the mean and the median. Now, we're going to talk about left and right skewed. And it always seems to me when I first look at left and right skewed, it is the opposite of what I would expect. But the way I remember this is that the tail is pointing. So if you were to draw the shape, in fact, if you look at my memes on the Canvas shell, I have the meme that looks like this. Now, this meme is left skewed, and you can see it's the tail, the longer tail, is pointing to the left. That's how I always remember it. And it is considered negatively skewed. The box plot, again, does not necessarily represent the histogram, is also left skewed, that the longer whisker is on the left. So sometimes I think the box plots are easy to determine whether or not it is left or right skewed. Left skewed means the longer tail is pointing to the left, and we considered it negatively skewed. In this case, the mean tends to be less than the median, and both are typically less than the mode. So the mean could be right about here, the median could be right about here, and the mode obviously here is number 7. So when we have a left skewed, negatively skewed, the mean is lower than the median, and the median is lower than the mode. Not always, but more often than not, that the median is lower than the mode. When we are right skewed, again, when we see that on my meme, we're positively skewed. And then in this case, what we see is that, I just got rid of that little picture, is we see that the tail is pointed now to the right. We call this positively skewed, and this would be a histogram that would be right skewed, and here is a box plot. And again, the whisker is longer on the right side. It is right skewed. We call this positively skewed. Now, when we talk about the mean, median, and mode, the mode is typically smaller than the median, and the median is generally smaller than the mean. So in this right skewed, we're going to the right, the tail is longer on the right, the largest number is the mean. The median is the next number down, and the mode is typically the smallest number. So this is right skewed. Now let's take a look at this example, and we don't have any of the histograms or the box plots, but it's asking me about the mean, median, and mode. So the mean age in the US population in 1980 was 30 years old. In 1991, the median age was 33.1 years old. And just a tidbit of useful information or not, the median age in 2022 was 38.9 years. So from 1991 to 2022, we went from 33.1 to 38.9. So what does this mean for the median age to rise? Now, we're not talking about mean as the center of the spread of the data. We're talking about how can we interpret the fact that the median age is rising in the U.S. from 1980 to 30 years, all the way to 2022 to 38.9 years. Well, what it typically means is that the population is aging and people are having less children. So when the median age rises for a population, that means that the population is aging and the population isn't having as many children to offset that age. So why could the median age be rising? Well, of course, one of it is that we're having less births over time. And it could also be that the lifespans have increased. That means the number of deaths have decreased. So that could be one of the reasons why the median age in the U.S. is increasing almost 10 years from 1980 to 2022. Now, taking into account that we did have a pandemic, so we had a bunch of people, unfortunately, pass away during that time, but the median age still did rise in that time frame. And that's because people are having less children and our lifespans are increasing. So for the median age to rise, is the actual number of children in 1991 less than it was in 1980? And that's not necessarily the case. In 1980, 50% of the population was 30 years old or less. In 1991, 50% of the population is 33.1 years or less. So if you look at the population median in 2020, that means 50% of the population was 38.9 years or less. That's what it means for the median. On July 1st of 1991, the population in the U.S. was 252.98 million. In 1980, the population on July 1st was 227.23 million. Since half the population in 1991 was larger than it was in 1980, the median, of course, would be greater. Therefore, there could have been fewer children, but then again, there could have been the same or more children. So just because the median age rise does not mean that the number of children are less. So the number of children could be the same, but we now have, so say there was, we'll do it easy. There was 10 children in 1980, and then there's 10 children in 1991, but the populations have increased from 1980 to 1991, but the same number of children are the same. So that's why we could have a median being much higher in 1991, because the numeric value of children could be the same, but if you compare it to the population size, which increased, and that's why the children actually having a bunch of children in 1980 or 1991, and if it's still the same number of children in 2022, your median age is still going to increase. So there is that. Now, let's take a look at this graph. The mode, the median, and mean, how are they all described? How would we describe the interaction? Who's the largest? Who's the smallest? Well, first of all, if I were to draw this, we know that the tail is pointing to the right. Now, when the tail is pointing to the right, that means the mean is the largest. And in fact, if you were to take this histogram and figure out what the mean is, like we did in the previous video, we know we can calculate the mean, and we'd find the mean to be 4.06. You can see the mode, just by looking at the histogram, is 3. And somewhere in there would be the median, and the way that we do the median is just like we did in the last video. We'd count that this has 8 pieces, this has 4 pieces, this has 2, 2, and 1. We'd add all of those up, and then add one more, divide by 2, so we know the position that we'd be looking at. And so if I do this really quick, I have 17 plus 1 divided by 2, which gives me position, it's 18, position 9. So we know it would be right here. So our median is 4. And just like we expected, the mean was the largest because it's right skewed. The median was right underneath that, and then the mode was the smallest. And that's it for this video, 9 short, 13 minutes. And if you have any questions, we'll talk about it in class.